today I'm just going to be finishing out 2013, like the walkthrough for the 2013 USNCO local exam. The reason I'm not going, 41 through 50 and 51 through 60 is that this back part is like super trivia based, especially for this year for some reason. So I'm just going to go over what I can explain, and some stuff it's just memorization. Okay, so starting with 41. You're given this equation. It's a redox reaction. And what will increase the voltage of the cell? So that should bring to mind the Nernst equation. So here, basically, since we have a minus sign after E naught, we want Q to get smaller. Like, if Q gets smaller, E will grow bigger than E naught because we have a minus sign here. So we essentially want Q to get smaller, and therefore this concentration to increase while this one either stays the same or decreases. So A obviously addresses that problem by increasing the concentration of tin 2+. B is literally the opposite of what we want to do. Oh, sorry, this is aqueous 2. So we want to increase the 2 on the left while decreasing the 1 on the right. C, opposite of what we want to do. D has nothing to do with our goals at all, so that's why the answer would be A. Number 42. Okay, what observations are made? So, obviously, it's electrolysis, so the E naught is going to be negative because it's being powered through some source, but we want it to be the least negative as possible. Basically, that means as close to 0 as possible. But we also have the constraints that we don't necessarily have all these reactants available. Like, if I wanted to do this reduction half reaction, the one that starts with O2 gas, I just can't because I don't start with O2 gas. I start with K plus and Br minus, phenolphthalein, and water. That's it. So you need to identify which reactions you can't do. Not can't do necessarily, but which ones can't go in the forward direction and must be reversed. So this one cannot go forward because we can't start with O2. This one can't go forward because we don't start with elemental bromine. This one can go forward, the third one, because we do start with water. This one also can go forward because we have a KBr solution. So because we're composing like an actual reaction, we need to have one oxidation and one reduction. So we need to pick from one of the bottom two and one of the top two and try to get as close to 0 but still below 0 as possible. So that would mean we have to flip these two because they can't go in the forward direction, so this would become negative, this also becomes negative, and we keep these two the same. These two are the same because we don't flip them. Let's see, how do we get as close to 0 as possible? I think we would have to add the middle two. Yeah, we would have to add the middle two. Because we're like minimizing the damage, right? So this is the closest to 0 by far. Oops, I covered the negative sign. That could be a little confusing. But that's the closest to 0 by far, and negative 1.07 is the second closest to 0. So if you add the two numbers that are closest to 0, you're going to get the option that is just closest to 0. So overall, E naught would be negative 1.87 volts for that reaction, and not going to balance, but that reaction would be... Oh, I don't have to balance. Okay, they're both 2 electrons. 2H2O, and as you can see, I'm also not writing states. But if you're on like National Exam Part 2, make sure to write states. OH minus. So there are things we can observe during this reaction, and let's take a look at the answer choices as to what those could be. Solid metal forms. Don't see any metal there. We'll skip B for now. Dark red Br2 forms. It's tempting, but I mean, one thing I find wrong with this is that they describe it as aqueous here and they describe it as liquid here. I mean, I guess that would make sense since if you make it, you have water, and if you start with it, you don't necessarily have water. But I'm gonna leave that for now because it doesn't describe it totally, right? It's not the best choice. If we go to D, bubbles form and the solution remains colorless. The reason that this is wrong is because the solution's obviously getting more basic because we're producing OH minus. So getting more basic, phenolphthalein has a pK of like 9 or something. So it goes from colorless to pink at about like 8 or 9. So it would look pink. And the reason we're going to choose B is that it says pink. It tries to emulate that with dark red here, but that's not necessarily right. The reason why this is right is because it mentions pink and the H2 bubbles. Okay, moving on to 43. This is what I was talking about earlier when it's literally just memorization. Rutherford he shot the alpha particles, right? And he discovered that the atom is mostly empty space with a centralized positive mass in the nucleus and electrons like scattered out in other places around the nucleus. Millikan did the plum pudding experiment, or not experiment, he made the plum pudding like model, which just suggested that everything is together in one sort of like pudding ball, like there are electrons just dotted inside the pudding of a positive mass, but that was proven false. So basically it's just D, you have to memorize it. 44, what's possible, or what's not possible. So if I just make this pyramid, it is also a somewhat memorization. I don't know if you've seen this before, but okay, I'll stop at the fourth n level. Basically, this pyramid is the order of energies of each orbital type, so you have to read it going like this. Basically, what this means is that 1s is the lowest energy orbital, then you have 2s, then you have 2p, then you have 3s. I'm reading in the arrows direction right now. Then you have 3p, then you have 4s because you have to read by the arrows, then you have 3d, 4p, and so on. So here, what we know this is not possible is that there's no 3f. So it's C. And you can see that every time you go up one number, 1n, a new type of letter opens up. I'm trying to be more articulate than that. I think that's called the angular momentum wave number, something like that. But anyways, 3f isn't possible. 45. Okay, so we know that it has an atomic number of 25, so we can automatically eliminate C and D because it's not transforming into some other element. We know that it's 2 plus, so it has 2 less electrons, which both seem to suggest. And then how many neutrons does it have? This one says 55, this one says 30, but we know that the mass number located in the top left signifies the sum of the proton and the electrons. So, or protons and neutrons, sorry. So that's why A is our choice. 46, I don't know why this is so far back in the test. Usually this is like questions 5 through 10-ish. What is the flame test color for potassium? It's just violet. That's something you have to know. 47, which one has the highest electronegativity? As a general rule, going up and to the right on the periodic table, you'll have higher electronegativities. So F would be the most electronegative element. 48. Which are both metalloids? If we just go to the periodic table, so I have here circled germanium and arsenic. This, they bolded it for us already. I'm not very good at tracing on this computer, but they already bolded it. Basically, anything on this diagonal can be considered a metalloid, like besides aluminum. So, these are all metalloids. So, B lined up with that choice. Silicon oxygen bonds in silica are best described as. Okay, so we know it's not nonpolar covalent, and we know it's not ionic, because these are relatively close in electronegativities, but they're not the same, which eliminates both of them. So we're going in between coordinate and polar. The reason it's not coordinate is because it's talking about the bonds between silicon and oxygen, and silica is a tetrahedral structure, but when it forms coordinate covalent bonds, it's between the oxygens. So that's why it has a super high melting point, for instance. It's because it's a coordinate structure, but the coordinate bonds are between the oxygens and not between silicons and oxygens or silicons and silicons. So that's why it's polar covalent. 50. Which bond is the strongest? Nonpolar, pretty polar, a lot more polar, less polar. This is the most polar, so I went with C, double bond O. 51. What's the relationship? Basically, you know their resonance forms because from here you just move one of the bonds to the left and then put a lone pair on the right, and then you get this. That's a resonance form. If A represents the central atom. Oh, okay. So basically, in order to draw Lewis structures, you have to count the number of electrons in each. So BF3, that should be 24, I think. Yeah, 24 electrons total, because 3 plus 7 times 3. So I guess I'll just draw them out for the sake of it. So we used 1, 2, 3, 4, 5, 6 already, and we have 18 to fill the rest. Oh, okay, yeah, so it'll just be lone pairs around here, here, and here, because B can just be hypovalent. So we would call this a 120-degree angle, because it's trigonal planar. CF4, it's 432, okay. We used 8 in making the bonds between C and F. We have 24 left. 6 times 24. I mean, 6 times 4 is 24, so we just have the dots around the F's. That would be tetrahedral. This is 109.5 degrees. So obviously A is already eliminated. Sorry that I'm not drawing the lone pairs. You know, I just want to go by it a little faster. NF3. This should be 26. So this time it's the same as BF3, except you have a lone pair on the N. So what is this? Slightly less than, hold on, slightly less than 120, I'm thinking. I haven't reviewed this in a long time. I should review it. Anyways, let's move on to OF2. Oh no, it would be slightly less than a 109.5. Oh. Because technically you have to consider this an electron group, so 1, 2, 3, 4, so it's trigonal pyramidal, but it's like a lone pair repels the other stuff slightly more than just a bond would. So that's why it's a little bit less than 109.5, because you're squishing the F's together a little bit. Here, same deal. It's for electron domains, but you have 2 lone pairs this time, so it's going to get squished even more. So it's even less than 109.5. So that's why we choose F. Did I say F? Okay, I meant D. 53. On the basis of Vesper, what geometry? SOCl2. Once again, let's just draw it out. S is the least electronegative, so let's put it in the middle. I think it's just going to have 4 things around it. Oh, no, I can't count. It's going to have 3 things around it. CLs are going to be at opposite ends. Okay, so if we count 6, 12, 14, 26, so it's just going to be like that with lone pairs around all the others to make octets, so it's going to be trigonal pyramidal. Ethyne. So that's just this, or you could like, okay, that's extremely messed up. That's not how you draw it. It would be this. But okay, so you have 2 pi bonds, 1, 2, 3 sigma. Okay, for 55, how many structural isomers? Okay, I'm going to let you guys on a secret. I don't do these problems correctly. I never have. Technically, you can do these correctly if you have the time, but generally, you won't have the time, right? Because you're going to be busy, like, reviewing the other ones. This is what I do. And it's a really stupid method, but for some reason it seems to work. So 1, 2, 3, 4, 5, 6, and we know this is an alkane because the number of H's is 2 times the number of carbons plus 2. So 1, 2, 3, 4, 5, 6. So 2, 3, 4, 5, 6. That's 1. And then you have a hexane here, right? You want to draw a pentane. 1, 2, 3, 4, 5. And then you want to put basically 1. You could draw it here, or you could draw it here, or you could draw it here. We're just talking about adding methyl groups to pentane. So that's 1 form plus 3 different types of substituted pentanes. And then from here, what do I do? Hold on, I got 5 somehow. Alright, you know what? Oh. Die substituted. You can do a die substituted, what is it called? Why am I blanking? Butane. Yeah, so 1 plus 3 plus 1 equals 5. That's how I do them. I just I start from the maximum amount in the longest chain that I can do, and then I go down by 1 each time, and then I substitute it as many times as possible and add them together. Not sure if that's the right way. Yeah, that's how I do them though, and somehow I usually get them right. All of the following are condensation polymers except. Don't know how to do this one. Protein is just not specific, so I'd X that out. I'd be choosing between nylon and polyethylene, basically. I don't know how to actually do it though. Once again, like I said, if you Google these and you go down that path, you can probably figure out how to do them, but they're just trivia. Methanol can be gently oxidized. What are the products? Okay, for this one, it's not really organic chemistry knowledge. You just have to know that an aldehyde is an oxidized form of an alcohol. And if it ends in Al, it's an aldehyde. If it ends in Ol, it's an alcohol. So, yeah, that's basically it. Which does not describe benzene. Benzene's the poster child for aromatic compounds, so obviously it can't be A. Undergoes substitution reactions. It's the poster child for substitution reactions, so it can't be C. I honestly don't know about D, but the reason it's not B is because it does not have 2 isomers, it has 2 resonance structures. Because if we draw out benzene, oh boy, can I draw a hexagon? It has this, and it has this, and these are resonance forms, and it doesn't exist in either. It doesn't vibrate between the other. It just exists somewhere in the middle of these. But the reason that this B is wrong is because they use isomeric instead of resonance. Well, wrong in terms of it doesn't describe benzene, but right for the question. All of the following atoms comprise part of a peptide functional group except this one. So basically, it's just logic. Peptide you use to build proteins. Hydrogen's just in everything. It's just in everything. Oxygen's almost in everything. Nitrogen, you find those in proteins. So it's just phosphorus. Okay, which vitamin is the most soluble in water? Completely guessed on this one when I took the test. Turns out I was right. The reason I didn't choose D is because vitamin D is in milk, and it's a colloid. Or more accurately, it's a suspension. So Yeah, I don't know what kind of logic that was, but I was just like, that's not super soluble, so let's not choose D. Did not know what K was in. I'm pretty sure it's in like spinach or something. And the reason I chose C, because I was just thinking of orange juice, and I was like, that's pretty much like water. But obviously, this isn't scientific at all. This is just like something you should have memorized. Realistically, no one's gonna memorize this, so if you can find any way to like logic it out, like I just did, good on you. But anyways, starting next time, I think I'm going to do 2014 locals just to like keep the streak up. But I might also just like jump over to do a national exam. All right, see you guys.